The greatest paradox of Roman history is that their military power rested not on superior weapons, but on unseen industrial and measurement efficiency. We overlook the mundane breakthroughs that allowed Rome to build, feed, and manage an empire of 60 million people efficiently. This is New Facto, ranking the 5 Roman inventions that perfected resource management, precision, and applied mechanical power, shaping modern industry. Our criteria: the ability to scale industrial output and standardize foundational processes we still rely on today, starting with the very accuracy of construction. 5. The Groma and surveying tools, precision measurement. The thesis, Roman mastery of territorial management and construction sequencing, relied entirely on creating and enforcing precise, standardized measurements across vast, difficult terrains. Technological leap. Tools like the Groma, a sighting instrument, and the Corabates, a sophisticated leveling device, allowed engineers to map terrain and maintain minute, consistent gradients necessary for aqueducts and straight roads. This was applied, practical geometry. Economic engine, standardized precision reduced errors, eliminating costly rework and ensuring the interoperability of infrastructure built by different legions in different locations. Accurate land surveying was also essential for equitable taxation. Societal impact. This level of measurement precision allowed for the massive, accurate grid systems of new colonial cities, the blueprint for modern urban planning in places like Manhattan. Metric. Roman surveyors could maintain a downward gradient of less than 0.05% over kilometers for aqueduct construction, demonstrating incredible precision. The real impact was establishing the principle that construction and administration require state-enforced, universal dimensional accuracy. Number 4. The Roman road network, logistics as a system. Rome didn't invent the road, but they invented infrastructure as a comprehensive, standardized, state-financed asset designed to maximize speed and longevity. Economic engine. The estimated 50,000 miles of paved road drastically reduced transport time, accelerating trade and facilitating the mass movement of goods, enabling agricultural specialization and complex supply chains. Technological leap. The multi-layered construction, including subbase, aggregate, and paving, was an engineered solution to water damage and soft terrain, ensuring the lifespan of the road stretched across centuries, greatly surpassing temporary tracks. Societal impact. This network was the primary driver of political cohesion, ensuring that provincial taxes, judicial decrees, and cultural practices were uniformly applied across the massive territory. Metric. During peak construction in the 2nd century AD, the road network had an estimated operational economic value totaling 10% of Rome's annual GDP. The real impact was creating the conceptual model for modern interstate and global logistics networks, prioritizing strategic connectivity over local convenience. 3. The watermill, applied mechanical power. While known globally, the Romans were the first to apply hydraulic power systematically and industrially to large-scale, continuous production, primarily for grinding grain. Technological leap. Roman engineers developed efficient wheels and the gearing mechanisms necessary to translate rotary motion into reciprocal force, allowing for industrial-scale processing of raw materials. Economic engine. The mechanization of grinding dramatically reduced the need for human and animal labor, particularly in urban centers, significantly lowering the cost of staple foods. Unseen consequences. The watermill represents the first major systematic application of non-human energy for mass production, laying the groundwork for the later Industrial Revolution. Metric. The Barbagal mill complex used 16 water wheels and was capable of grinding 28 tons of grain per day, enough to feed over 80,000 people. The real impact was demonstrating that industrial production requires the systematic application of external mechanical power to achieve scale. Number 2. The arch and vault, mass-produced strength. This fundamental architectural unit allowed structures to be built faster, taller, and wider than ever before, efficiently distributing load using compression. Technological leap. Mastery of the keystone diverted massive downward forces laterally, making structures vastly more resource efficient than post and lintel systems. This innovation enabled the rapid construction of monumental architecture. Societal impact. The arch and vault were essential for large-scale public amenities, baths, markets, amphitheaters that supported millions of urban dwellers, defining the communal experience of city life. Economic engine. By reducing the required quantity of interior supportive materials, the arch and vault significantly lowered the total material and labor costs for major construction projects. Metric. The Roman baths of Diocletian, completed in 306 AD, covered 130,000 square meters using massive vaulted ceilings, demonstrating the scale unlocked by this system. The real impact was providing the universal, efficient structural geometry foundational to almost all large-scale compression architecture. Number 1. Opus Commentisium, Roman concrete, the material of eternity. The thesis: Roman concrete is the most important infrastructural invention, providing the cheap, durable, and flexible mass production material that is the basis of our modern built environment. Technological leap. The binding agent, including pozzolana volcanic ash, gives the mix a unique chemical property that makes maritime structures stronger over time, a feat of self-healing material science modern engineering still seeks to perfect. Economic engine. Its low cost and ease of use allowed Rome to scale up building projects faster than any civilization before, bypassing the limitations of skilled stonemasons and expensive quarrying. Unseen consequences. Its versatility allowed the Romans to cast complex forms, culminating in engineering marvels like the Pantheon's unreinforced dome, a form that was impossible with cut stone. Metric. Modern concrete remains the most consumed material resource in the world after water, a position held since the Roman revival of the technique. The real impact was providing the durable, flexible, and affordable mass production material that makes skyscrapers, tunnels, and foundational infrastructure possible today. The Roman pursuit of scale and precision reminds us that the right tool used systematically can conquer geography and time itself. Follow New Facto to unlock more historical breakthroughs.